Welcome to this lecture on SSL Handling and Oracle Cloud Infrastructure. So to use SSL with your load balancer, you must add one or more certificate bundles to your system. Now the certificate bundle you upload includes the public certificate, the corresponding private key, and any associated certificate authority certificates. And for the easiest workflow, upload the certificate bundles you want to use before you create the listener or backend set you want to associate with them. So the load balancer service does not generate SSL certificates, and it can only import an existing certificate that you already own. And the certificate can be one issued by vendors such as VeriSign or GoDaddy. And you can also use a self-signed certificate that you generate with any open source tool. So what does Oracle Cloud Infrastructure Load Balancer support? It supports SSL termination. Basically, it means that no encryption happens between the load balancer and backend set or backend server. SSL tunneling, where the SSL is implemented between the load balancer and backend servers. And finally, end-to-end SSL, where encrypted traffic comes in from the client and it is encrypted all the way to the backend servers. So you can easily tell if SSL is enabled from the UI itself. Here we can see we have two web servers that are being accessed and they're part of the backend set. The load balancer has an IP set, and on the listener side you can see that SSL is not enabled. Here we're just showing a couple of commands to generate the private key and certificate signing requests that can be done from a terminal if you have a Mac, or Git Bash or some other tool that you use in your system. And then some additional commands to generate a self-signed certificate. And then you can convert the certificate to a PEM format and then basically load the certificate into the load balancer. Then you can create a listener. In this case, we are creating a listener to listen on port 443. We specify a name, protocol, the certificate. We specify the backend set that contains the backend servers running the application, and then specify any kind of firewall rules, in this case opening port 80 and port 443. And once all the configuration is done, SSL termination is enabled for load balancer. The self-signed certificate implements full encryption, but it will cause a browser to present a warning message when they try to access this public site. Next, we'll look at some troubleshooting guidelines and load balancing metrics. So the load balancing service provides a health status indicator, and that they use your health check policies to report on the general health of your load balancer and the components. And you can see the health status indicator on the console. On the console's list and details page for your load balancer, backend sets, and backend servers. You can also use the load balancing API to retrieve this information. So what are some of the common issues and some troubleshooting guidelines? If you are seeing some concerning status on the console or UI, maybe your compute instances have misconfigured route table, you have a misconfigured listener, for example, listening on the wrong port or the wrong protocol. Your health check is misconfigured, where either the protocol or the port that you're listening on is misconfigured. that could cause a false health indicator on the UI of the load balancer or the backend set. Now this health status is updated every 3 minutes. And as of now, it is at default at 3 minutes, and no finer granularity is available for now. So you can monitor the health, capacity, and performance of your load balancer by using metrics, alarms, and notifications. The load balancing service metrics, they help you measure the number and type of connections and quantity of data managed by your load balancer. You can use metrics data to diagnose and troubleshoot load balancer and client issues. The metrics, they also help you analyze the HTTP responses returned by the server in your backend set. And you can see some of the metrics listed here: region, listener name, resource ID, backend set name. So these all help you monitor the health and performance of your load balancer. So here are some details on the metrics that we can monitor, and these include, bytes received, bytes sent, accepted SSL handshake, accepted connections, active connections, and quite a few other metrics that can be monitored to check on your load balancer's health, capacity, and performance. So in summary, Oracle Cloud Infrastructure's load balancer provides you multiple options: session persistence, virtual hostname, path-based routing, SSL handling, and then there are different metrics available to monitor the health, the capacity, and the performance of your load balancer. So here are some links to the free tier for Oracle Cloud Infrastructure, some training URLs, and hands-on labs that we offer. Thank you for attending this lecture.